Hello, good morning, welcome to
Cutting Rainbow.
With me.
The Chief.
Now, I'm here again, live streaming. I hope this is working. And before I get started, I just want to kind of like awkwardly bouncing. Can you hear my voice this time? Can you hear the music also? And is the balance between those two things okay? Please let me know in the chat. So welcome, my name is Dan. I'm here again this morning at the School for Poetic Computation here in the West Village of New York City. I think I'm going to stop the music. And I'm broadcasting live to do coding tutorials and other goofy, embarrassing, weird things that I can think of or not think of to do today. So if you happen to be watching this as an archive on YouTube, I recommend that you check the video description where you will find time codes to where various things happen during the course of this video. Also, whatever happens in this 1 to 2 hours that I'm here live streaming, video tutorials will get edited out of this content as separate videos. So if you're sitting here watching and looking at this, there's this 2-hour video, I can't possibly stomach this. You can turn this off and go outside and have a bike ride or a nice, piece of fruit and enjoy the sunshine if there's sunshine where you live. Or you can also, if you wanted to watch something on YouTube, you could look for the edited videos in my YouTube channel. So I'm going to take a look at the chat. Balance is good. Everything sounds great. Awesome. So let me talk a little bit about what I am planning to do today. So I have been doing a series. I've been doing many different series, but most recently I've been doing a series about working with sound and programming and coding, in particular in JavaScript, in the browser, using the P5JS sound library. So I'm going to continue that today. I was very lucky to have a viewer, contributor, colleague, friend, internet, social media person that I have been in contact with who created this wonderful website and GitHub repository. I'm showing you the link right here. It's s-f-x.xyz. Arno Farr of studionora.ca created this sound effects repository. And there are all sorts of fun... Oh my goodness. That one's actually not scary, but a little free and open source in a way sound effects you can use. And I can say to you, hello, and welcome to
Cutting Rainbow.
With me,
The Chief. Cutting Power.
Anyway, so I got lost in my own thoughts of playing with these sound effects. So at some point soon, by the way, I'm planning to set up a whole separate soundboard that I can just like press buttons on and play. So if you have any fun sound effects you think I should use during these live broadcasts, please make them and send them to me. They can even be bastardizations of my own voice messed up or whatever. Okay. But anyway, I'm showing this to you, but what I'm very excited about doing today in this particular live stream is actually putting this away. Because what I want to do today is talk about sound synthesis. How to make sound from nothing. So here's a way you could do sound synthesis. Me, 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 me. Me, 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 me. And you can see why I'm here doing tutorials about coding, because really all I wanted to do was be in the musical theater. But I can't sing. I try. I could sort of play the piano rather poorly. I played violin for a while. I love, musical theater. It's one of my favorite things. Someday I'll find a way to bring this all together, which is maybe today. But anyway, sound synthesis, that's the thing that you do with your voice. And you make your vocal cords vibrate, and it makes the air vibrate, and there's this sort of wave that's a vibration. I want to talk about how that works, as much as I can possibly understand it in my own head, and look at code examples to make that happen in code, in which case you could program an interactive piano, something that uses some mathematical algorithm to play a tune, all sorts of exciting possibilities. So that's one thing I want to look at today. Another thing I want to look at today, I think, is to continue I've been doing a bunch of different coding challenges, generally about topics in maths. Since I have an international audience, I feel like I'm allowed to say maths, because that's how I like to say it. All this kind of stuff looks quite scary and it just looks scary and like uncomfortable. But I'm here to do more videos about them to make these maths concepts friendly, hopefully. What was I going to say? Yeah, so I did something about something called the superellipse. And I said after the superellipse, I would do something called the super shape, which is this formula. And after that, I would even try to do super shape in 3D. So I'm building slowly, carefully, with some neurotic trepidation towards seeing if I can make this stuff in processing. But today I hope to get to this particular formula and what it makes and how you program it. Yeah. So I'm looking at the chat, and so far there's one vote for maths. Excellent. I agree, it's the correct way. I spent almost 1 year living in England and had a wonderful time there. So welcome to all you UK visitors, viewers. Invite me to come visit your fine country. I would love to come. Again, okay, so what was I doing? So now what I'm gonna do is I'm gonna take a momentary break from just kind of talking, and I'm gonna dance. Because this helps me clear my head and get some energy going. My moves were much better last time. And what I'm going to do is I'm gonna start getting set up. So, I need the Atom editor. I'm gonna open that up. I'm gonna close this, remove this project. Sorry, I've got a bunch of random things open that I don't need to have open. This I do want to have open. And what I'm looking for on the desktop here is P5JS sound. So I'm gonna just copy this play song, and I'm going to call this Sound Synthesis 01. And I want that to be open in Atom. That didn't work. Okay, great. And I'm going to close these. I don't need this file anymore. Move to trash. I'm going to go here. I'm going to get rid of everything in this sketch to start from scratch. I really should do this before I turn on the video. And then this is I'm gonna keep this open. This is for later. I think I can close these and remember them. Oh, I forgot to mention. If you're interested, this is my, if you're interested in more, you can go to codingrainbow.com. There are buttons for you to subscribe on YouTube. I also am running this thing called a Patreon, where you can subscribe to participate in a Slack channel where a bunch of us discuss and answer questions about the channel. Here's my most recent video, which was about the Julia set. And you can also, if you want to know when I'm doing live streams, you can put in your email here. I send out emails every once in a while giving you an update about the next time for the next live broadcast. Okay, so I wanted to mention that. I can close this tab, I can close this tab, and now I need to go to localhost. So I need to run my server. Come on, terminal. And go back to localhost, and I'm looking at, okay. Come on, where am I? There I am. Now let me run my server and sound synthesis. Okay, we're in good shape. One thing I want to do is make sure I'm using the most recent version of P5. So I'm just going to check also. Ooh, March 4th. No, this is distinctly not the most recent version. So let me update that. Apologies for doing my setup during the live broadcast, but so I'm just gonna, this is the version I want to be using, by the way, 0.5. This is the version at least I'm using today, 0.5.2 as of June 7th. Whoa, that's today. There's a new version as of today. That never happens. That's very exciting. Good thing I checked. So let me download that. And now I'm going to grab this libraries folder. And I'm going to go to my sound thing that I'm working on and paste that in there and hit replace. Close all this stuff out. refresh, it's still running, go to Adam, and we should see, I think I crashed things by, I don't know what I did, but let's force quit Adam. And come on, force quit. There we go. And now I am going to, Oliver's asking, did I record to disk? Yes, I have. Ooh, there's a new Instagram API. I'm looking at the chat. Yes, so a couple things. I didn't know that there's a new Instagram API. All of my examples that work with the Instagram API, I'm using like a really old Instagram API. The reason I'm using that one is because it doesn't require OAuth, which is this like, oh, I forgot I have a new thing to talk about. Okay, I'm gonna get to that in a second. What did I look at? All my files. Okay, hold on. You guys in the chat are making me all crazy. Yes, I am recording to disk. I am recording to disk. I am 10 minutes in recording to disk, yes. Okay, so hold on, time out. Okay, so first let me just get back to where I was. I wanna have this sound synthesis example open. And you know what? I'd rather actually just open this full directory into Atom. Seriously? Atom is not a thing here that I can just drag to. What is this world coming to? It actually even opened. Okay, June 17th. Excellent. Okay, now there's my sketch. Okay, I have something to talk about. Okay, a couple things. One is the reason why I was reminded of this is that okay, so somebody asked in the chat. I don't remember who. I was doing so well. I got panicked. Okay, somebody asked about Instagram API. So I do have some examples, and I'm actually going to show you where one of these. I have them probably in a variety of places. I probably even have them in the Coding Rainbow code repository, but I'm going to go somewhere else. I'm going to Google something called programming from A to Z Schiffman. See what this gives me. Okay, I'm looking for. Boy, the actual correct link that I'm looking for shows up nowhere in Google, which is a bit of a problem. But this will do right now. I'm going to look for this particular GitHub repository, Schiffman/A to Z F15. I'm really getting sidetracked here, but I have a point to this. Now, I'm also going to, since I know what the URL is, I'm going to go to schiffman.github.io/A to Z F15. So here is a website. And you can see this site holds my notes and examples for the ITP Fall 2015 course, Programming from A to Z. This is a course about programming in JavaScript and programming with text. So it's all about what happens when we, the people who are doing the programming, when you, think about creative applications of text, essentially possibly even without graphics. This could, for example, a piece of this might be sentiment analysis. I'm going to read this speech by a politician and try to determine whether it was a positive or negative speech. This could be about generating poetry through algorithmic ideas, analyzing and generating text in creative algorithmic procedural ways using JavaScript. That's the core idea of the course. So one of the pieces of the course is working with APIs. So that's here under week 4. And here there is an example for working with the Instagram API. So I'm curious, I wouldn't be surprised if this example is broken right now. Let's just see. So I'm going to click on this, and it's got the term generative in there. I'm going to click search. Let's see what happens in the console. Okay, so it didn't work. So I have a feeling based on what was written in the chat that the Instagram API changed. I was actually using a very old Instagram API that didn't require this kind of awful server-side authentication called OAuth. So I need to look into this. But the reason why, and possibly do a new tutorial about it, the reason why this reminded me is I have what I think is possibly an announcement, which is that, also related to somebody else's question in the chat, isn't it Patreon? So yes, so there is something called Patreon. It's like a Kickstarter-like service. I'm going to click on it here. And what I have is that for people who join Patreon, I have a private Slack channel. So this is a way to do some fundraising for my channel, for expenses that I have, as well as possibly someday in the future. I really haven't broken even yet, but generating income from doing this. Now, one of the things, in the fall, in September, I go back to teaching at a place called ITP. It's a program at Tisch School of the Arts, New York University. There's 200 students. It's a master's program. This course, there will be a site that says A to Z F16. So my plan in September, if I can make this happen, is to make, so every single one of these weeks, if I go back now to here, if you look at all of these weeks, I want to, as it's a 14-week course, or you can see there's 11 weeks of content, I'm planning to make YouTube videos about every one of these topics. Regular expressions, Markov chains, closures, Node and Twitter bots, Chrome extensions. I'm going to make weekly videos about these topics. So everyone will have access to that if you're watching the live stream or subscribing to my YouTube channel. And what I would like to experiment with is, so I have about 16 or 18 students taking the course in person at NYU. And then if you are subscribed to the Patreon in the fall, what I'll do is post the assignments in the Slack channel, as well as provide a forum for people to post when they did the assignments and have a discussion and answer questions about those assignments. So what I would like to attempt to do is teach the course both in person at ITP as well as in the Slack channel. And let me be very clear about something. I have a particular point of view about this, and I know I'm going on way too long about this, but you're here watching, so you're listening. You can turn this off if you want. To me, the course itself is not the content. I mean, that is part of it, in truth, of course. But to me, the course itself is the thing that happens in the physical space of the people being together discussing the content. So to me, I'm going to take the content and make that videos. I will be talking about the content and presenting that content in class as well. But that physical in-class thing is the class. So I want to see if I can create some sort of online community that an experiment in also having that, seeing if I can get that experience somewhat through this online community. Whether this means I need to try doing some Google Hangouts or whether the Slack channel will be enough, I don't know. But this is my idea for the fall. So when you contribute money on okay, anyway, so there's a discussion about Patreon versus Patron, and maybe I've written it incorrectly on the website. I'll figure that out later. But anyway, so I don't want to go on for way too long about this, but this is something I'm thinking about. If you have ideas and feedback about how to do this well, please let me know. Okay, so it's also like this has been on my list of topics to make videos about, and I can't figure out to find the time for it. So I'm kind of all this stuff I'm now putting aside. I'm going to do this stuff weekly in the fall since I'll be teaching this course. I feel like it's good synergy. Boy do I hate that word, but I'm going to say it, synergy. Okay, all right, so off that. So now let me go back. I am, okay, here I am. Let me get back and ready now for looking at sound. So I'm going to start with sound synthesis today. Okay. Is there something on the back of this t-shirt? There's not. Okay. Okay, so here I am. Here's the example that I'm going to program. Here's my outline. So I'm here on sound synthesis, and now I want to look at something. So I want to look at something with you guys. So I have a PDF. This morning I decided, okay, I'm going to do sound synthesis on the live stream today. So I better learn how that stuff works. I'm not really an audio person, audio expert. So I assume this is going to be one of these situations where on Twitter for the next 24 hours, I'll be posting all sorts of corrections of things I get wrong. And I was kind of Googling around, reading stuff about sound waves and that sort of thing. And then I realized, oh, I think I have a chapter that I apparently wrote with help from many other people in the learning processing book, a book about learning code with this thing called processing, about sound synthesis. So I thought what I would do is take a minute to kind of look at this chapter on this section of a chapter on sound synthesis, read a little bit of it with you guys. It's kind of like, do you know there's a television channel here in New York. It's called New York One, and one of the things they do, I don't know if they still do this, that I absolutely love is in the morning, they'll read the New York Times, the newspaper to you. So you could turn on your TV and have I don't know if it's a soothing voice or not, reading the newspaper to you. I always loved that. It's such a quaint thing that you just think wouldn't exist in the world anymore today. So I'm going to read this book to you in order to review in my head some of these concepts, waveforms, frequency, pitch, period, amplitude, and sort of understand what those concepts are, and then look at applying those concepts in code. And my trajectory is, and give me some feedback in the chat if you want, basics of sound synthesis, so creating a waveform and hearing that waveform, manipulating that waveform in real time with maybe sliders or something, then looking at what's something called an envelope, which is a way of kind of having a way of creating a synthesizer in a way, so that that you have a sort of a sound fading in or fading out with an attack. There's what's an envelope allows you to make something that sounds more like playing the piano or playing an electric piano, and then looking at how, if you know the specific frequencies of certain notes and you know a specific melody, you can have a sketch play that melody. And maybe I'll even do something like use an L system to generate a tune or something like that. Okay, Alvaro in the chat writes, please sync whatever you're going to do with something you already did. I don't know if I completely understand that comment, but I do mean for this to tie together as a sort of series of sound tutorials, so that there is kind of a narrative here loosely. Okay, so let me review. I need to review some of these concepts in my head before I begin the actual coding tutorial. So I'm going to read to you from my book. Okay, so let's think about that. I'm actually not going to just really read it. Okay, so let's think about a physics of sound. So the first thing we need to understand is physics of sound. Sound travels through a medium. Sound exists, most commonly air. This is something that I wrote. But also sound can travel through liquids or solids. And as a wave. So if a speaker vibrates, or if you pluck a string and it vibrates, it's creating that wave to travel through the air and arrive at your ear. And so, a common form of a wave would be like a sine wave. Let's come over here for a second. Oops, this camera is off. This is me, by the way, practicing the content of the tutorial. Because I have to, and I guess I'm gonna erase what I have here. I'll take a peek at the chat in a second. So if we have this idea of a wave, this like a pure form of a sort of perfect wave, might look something like this. This is actually a kind of wave that you'll see if you graph the mathematical function sine. And so this is like a wave that could travel through the air. And this wave would have things like an amplitude, which is the height, amplitude, the height of the wave. It has things like a period. So a period is how long is one cycle of the wave. So you can see here that like this is a full cycle of the wave. It repeats. So this would be the period. How long did it take for the wave to repeat itself, like in time? And then frequency is like 1 divided by period. So how many repetitions in 1 unit of time? So something like 60 hertz, that's like 60 repetitions in a second, I think. I think I put this in the book. Okay, somewhere here, hertz. 1 hertz is 1 cycle per second. Okay, audible frequencies typically range between 20 and 20,000 hertz. Okay, so then I think that's basically, then the idea is that we want to create, and this is processing code, I'm going to have to do the P5JS code, but the idea is to create an oscillator, and then you can set the frequency and amplitude. So you're essentially configuring the wave and hearing it. Okay. Angular frequency is clearly better than frequency. I don't know what angular frequency is. So if anybody wants to fill me in on that, you can let me know. Okay, sorry, I lost my, I have this problem where I'm trying to have the chat zoomed in and I screw it up. I just want to check, I'm just curious. Let's see here. If anybody's watching in Twitch, I think I might stop streaming to Twitch. Because there's only 4 people watching in there. But we'll see. Okay, so where am I here? Okay, so so this is the idea. So let me see here. Let's look actually also now on the P5JS website. So this, okay. So this is how it works. You make an oscillator, set its type, frequency, amplitude, start. So I think I'll be doing this in an example, and if I click, what happens when, oh, click. Oh, look at this. You can like ramp its amplitude to 0.5 over 0.1 seconds. I think that comment is incorrect because it's point over. So that's interesting. There's lots of interesting possibilities there. Can you hear that? So that's, so let me just, I'm just running on the P5Jest website. If I change the frequency to like 400, click again. Now there's a nice little, so the amplitude was set, in this example the amplitude is set to 0, and then, so interestingly enough, let me set the amplitude to 0 without this fade in. Just curious to, so you can hear there's a little bit of a clipping right as it starts. So that's why it's nice. So this is something that I can add to my example. If I put like 5 seconds, it would then over 5 seconds. And let me actually set, I can barely hear it. So let me set the amplitude to higher over 5 seconds. Can you guys hear that? And now it should be fading out over 5 seconds. I can't tell. Anyway, I'll fiddle with that when I make the example. Okay, so, and now the other thing I want to look at is P5 oscillator. Reference, so I think actually for sound I want to go here, and then I want to go to P5 oscillator. And start, stop, set type. So these are the kind of types. Sine, triangle, sawtooth, or square. And I, you know, from my understanding is it's just sort of describing what the waveform looks like. So let me see if I can get this right. Triangle, I believe, is this. I'm going to do this again in like a video tutorial. That's probably triangle. Square would be like this, maybe. What's sawtooth? Let's look that up. Sawtooth wave. Aha. So sawtooth, oh, look at this. Here's a nice image of all the different waves. So these are the different waveforms: sine, square, triangle, and sawtooth, and they'll have different different audio. Angular frequency is usually used for FFT, and the like in real applications it's more intrinsic, avoids factors of 2 pi. So yeah, so that's beyond the scope of this particular tutorial video. I know my camera went off. I still haven't figured out the magic lantern settings for these cameras. Okay. Yes. Okay. Alvaro is mentioning sync. Yes, I'm going to do the super shape today. Before I leave, it's about 11:15. I'm going to do the super shape today. Yes. Okay. Okay. So these will have different audio qualities. Wonder what this. And I don't know that in. Yeah. And then here are specific frequencies for certain musical notes, and then I'm getting into the envelope thing. Okay, and then this is the sort of MIDI conversion. Okay, so maybe I'm going to get into all of this. Noise is something we can talk about, but I might skip that. Okay, great. So I think I'm ready for this first tutorial. In the chat, I'm going to erase the whiteboard, get myself set up with the code. If I've missed anything fundamental, do anybody in the chat thinks of like core sound synthesis? Please let me know. Okay, so I'm coming over here. Oh, by the way, how's the focus on the whiteboard? Let me know in the chat. I don't feel like checking it, but I will if I need to. Okay. Yeah, and somebody in the chat mentioned Chuck. Sorry, I'm looking at my phone. This is like the worst thing. You know, by the way, the worst thing you could ever do as a teacher in a real classroom is be like, "Excuse me, I'm getting a text." Students do not like it. First of all, it's rude, but I don't know why I think I could do that on a live stream. The problem is it keeps buzzing, and I'm worried that it's like an important message about you know, something wrong with the live stream. But I'm putting that away. Okay, I have no idea what's going on anymore. Coming back, sound synthesis. Okay, so I'm getting myself ready. Yes. Trevor in the chat writes, reminds me of the programming language dedicated to sound, Chuck, which also has some lessons on Contemze. Yes, so one thing I should mention is if you are interested in audio as a form of creative expression, and in particular computational audio and programming with sound, I'm not suggesting by any means that P5JS and the sound library is the sort of perfect, most comprehensive place to do this. In fact, there are audio environments like Max MSP Jitter, which is commercial software. There's Chuck, which I believe is open source and free. Actually, I have no idea if that's true. And there are courses, online courses, and actually there's a great Sam. There's someone named Sam, and his last name is, who does great YouTube videos. So we'll post a link to it in this video description. Anyway, Sam does great Max MSP video tutorials on YouTube. You should check those out. I'm sure they're going to be much better than this one. There's a couple things that I like about using P5JS. One is I'm already using it for other stuff, so it makes sense to do it here. The sound library, which was created by Jason Siegel, is excellent and has a lot of great features. And it also means you can do the stuff in the browser. So if you want to do sound stuff in the browser, JavaScript and the web audio API in P5JS is great. There is also, I should mention, a sound library for the browser called Tone.js. And I certainly won't be today using Tone.js, but certainly if you're interested in sound synthesis, this is probably something you want to take a look at. But I'm going to look at the basics of it in P5JS. Pure Data. Thank you. Mathieu mentions Pure Data, which is an open source data flow programming environment, much like Max MSP, which is free and open source. Okay. So here we go. So now I just need to, I'm going to keep this image up in case I want to reference it. I want to, here's some possible screenshots for the sound synthesis tutorial. Thumbnails. That's one possibility. Since there won't necessarily be a lot of visual, this is another one. Some thumbnail possibilities for Mathieu, who will make a thumbnail. Let me find the YouTube Max tutorial. His name is Sam, YouTube Max MSP. Let's see if this comes up. Yeah, I think this must be, is it Dude837? Yep, that's Sam. It doesn't say his last name, but that's fine. This is Sam, and this is his YouTube channel, Dude837. Give him some more subscribers. If you're interested, great Max MSP tutorials. Okay. Now, where was I? I gotta get into okay, so here we go. Let me close this out. This is good to have open, the oscillator reference page. I'm gonna keep this open. I'm gonna make that a little bit bigger. I don't need my Patreon open. I don't need this open. I need this open. Sure. Actually, I'm gonna close this right now. This I wanna leave open. Here we go. And then now this can go away, and this can come up. And I think now I'm ready to start. So what should be my opening image? Actually, maybe I will have this as my opening image. Actually, view. Table of contents. Sorry, everybody. I'm like being overly. How do I get rid of that? Oh, okay, hide sidebar. There we go. It's obviously really important what I'm doing right now. Okay, so this will be my opening image. Thumbnail possibilities. Okay. Oh yes, and you can program in JavaScript in Max MSP. You can program in Max MSP with like JavaScript stuff. Okay. Let me cycle the cameras. I'm very excited about this tutorial. It's not something I'm ever really talked before or feel super comfortable with, but I hope that people will find it interesting and useful. And I have everything going. So I'm ready. I've got my button to go back and forth. I've got my mind, which has many flaws to it. And I think I'm ready. Okay, my processing t-shirt. And here we go. Okay, I'm gonna clean my glasses. And here we go. So I'm going to do what I hope will be about a 10 to 15 minute tutorial on sound synthesis in P5.js. And I'm going to mostly try avoid looking at the chat while I'm doing this tutorial. This will get edited as a separate standalone video. And then when I'm finished, I'll look at the chat to see if you'll have comments or questions or corrections. OK, here we go. I'm doing this from scratch without, I just want to look at one thing just to have my mind refreshed. New p5.oscillator. OK. OK. OK, here we go. Hello, welcome to a video tutorial about sound synthesis in the browser in JavaScript using the P5.js sound library. Okay, so what is sound synthesis? The idea here, unlike my previous videos where I loaded a file from a sound and played that sound, whether it's music or a sound effect. Boy, do I really wish I could. Okay, hold on. Sorry, I couldn't redo this because, because I'm a crazy person. I gotta be able to, what's a good sound effect here? Yeah, that's a good one. Okay. Oh, actually, I'll just use the coding rainbow.
Coding rainbow.
Okay, I'm doing this again. Sorry. Okay, here we go. Try attempt number 2. Hello, welcome to a video tutorial about sound synthesis in the browser using JavaScript, using the P5.js sound library. Now, this is one part of a continuing series about programming with sound. And what I'm going to do in this particular video, which is quite different from my previous 4 videos, is instead of loading a sound from a file like some music, or perhaps playing a sound effect like
Coding rainbow.
what I'm going to do is instead create, in a way, sound from nothing, sound synthesis. Now, of course, I could do sound synthesis myself. Me. Okay, I can't sing, it's terrible. But this is the idea. My vocal cords are vibrating, and they're creating a vibration. That vibration is traveling through the air, and it's actually going into a microphone. The microphone reads that vibration, records it, then it's coming out of the speaker of your computer, which is vibrating and then traveling again through the air and eventually into your ear. So this idea of a sound wave is something we need to talk about, this wave that travels through the air. How can we encode, synthesize that wave, create a sound, and then control that wave to essentially play a melody, play a tune, create an interactive piano? All these types of things are possible with what I'm going to show you how to do. So the first idea is really to think about a sound wave. So let me come over here, and there are a couple key concepts which I think are quite important. So what I'm going to draw for you here is something called a sine wave. Now, I'm sure I am not drawing this exactly correctly, but if you take the sine function being a function from trigonometry, if you have a triangle and you take sine of theta, it equals the length of the opposite side of the triangle divided by the hypotenuse of the triangle. So you can go and look at all my trigonometry and triangle tutorials and stuff somewhere else. That's not really relevant for here. What's interesting is if you think of this angle as a value that's changing over time and were to graph that, you're going to see a wave pattern like this. So it's a perfectly symmetrical repeating wave form, a sine wave. And if that sine wave travels through the air, you're going to hear a tone. Now, a wave has certain properties. One property is amplitude. So if we can look at, this is like the top of the wave, and this is like the bottom of the wave, and you can think of that height as something called amplitude. So the height of the wave. And now the height of the wave is actually, is actually a volume. So the higher the wave, the louder the sound, the amplitude. I mean, I'm sure there's like a very fine, nuanced scientific distinction between those terms, but we can think of it for right now. Somebody will yell at me in the comments in the chat, and I'll feel very embarrassed and sad and that I got everything wrong. But anyway, so amplitude, that's the height of the wave. Now, another key part of the wave is something called period. So period, and I'm gonna, like this, is the amount of time, or the length between, the length of a full cycle of the wave. So you can see from here, this top of the wave, all the way to here is one full cycle that just repeats over and over again. How long it took for that cycle is the period. And in the case of sound, we're really thinking about time in seconds. How many, that wave, like how long did it take for that waveform to wave, so to speak. Now, 1 divided by period, 1 over period, is a term called frequency. Meaning not how long for one cycle, but how many cycles per second. And this is actually a measurement you've probably heard, hertz. So if something is 60 hertz, that's a frequency of 60 cycles per second. And this is key because what we're going to do is we're going to create a wave with code. We're going to set its amplitude. We're going to set its frequency as a value in hertz and then listen to it. So these are the concepts. What I want to do now is look at how do I, in JavaScript, create this waveform and control its amplitude and frequency. Okay, let's go and do that now. So coming over here, I think I'm back over here. And here you are, here I am. I'm going to play some music for a second just to get my mind centered. Okay, that's good enough. And now I'm going to minimize this. I'm going to open my browser open over here, and I'm going to go to, this is an example I have running. So I have a completely empty blank canvas. I don't actually need a canvas for this example. I'm just doing stuff with sound. I'm going to go back to the code, and I'm actually just, for the sake of argument, going to make the canvas a little bit smaller so it takes up less space on the page. Okay, so what do I need to do first? I need to create a sound wave. So what I'm going to do is I'm going to create a variable. I'm going to call it wave. And technically the term for a wave in P5JS sound library is oscillator. A wave being something that oscillates, much like plucking a string, right? You pluck a string, it oscillates like a wave, and it vibrates through and pushes that wave through the air up to your ear, you hear a sound. Okay, so what I need to do is say wave equals new p5.oscillator. So this is a new object you might not be familiar with, p5.oscillator. Now I've created an oscillator object. So this object exists. It's up to me to turn it on and turn it off, to set its frequency, to set its amplitude, to configure that oscillator, so to speak. One thing that I think is important for me to mention is that here in index.html, I have a reference to the P5JS sound library. You can't really see it all the way there. There we go. So you need to, for this to work, you need to make sure you have the p5.sound.js file loaded as part of your project. So now I'm back to here. The other thing I think is worth showing you, and I have it here, is the reference page for p5.oscillator. So this is something you might want to look at on your own time and review. There's actually a nice little example on this page, but I just want to show you, here are a bunch of the functions that I'm going to start to demonstrate to you. Start, stop, amplitude, frequency, set type, connect, disconnect. So there's a lot of, all those things I showed you about manipulating a song file, an MP3 file that you load and play. There's similar things going on here. So one thing that's really important though is this idea of set type. So look at this. I talked about sine waves, but you could also have a triangle wave, a sawtooth wave, or a square wave. And I actually have an image here. I was going to draw these as diagrams, but I'll just use this image instead. So what the waveform actually looks like is going to determine what the sound sounds like. And of course, the world is your oyster in terms of possible ways that you might be able to do sound synthesis, but P5 by default allows you to create oscillators of these 4 forms: sine wave, square wave, triangle wave, and sawtooth wave. And this image comes from Wikipedia, and I believe this is a Creative Commons licensed image. I better check that, but hopefully I'm pretty sure it's available to be used in this video, and you could also use it as well. Anyway, okay, so I'll post a link to it in the description. Okay, so we'll try a bunch of different forms, but let's just start with a sine wave. So the first thing I want to do in my code is say wave.setType, and I believe I need to pass in a string, meaning a word in between quotes, sine being sine wave. The other thing I could do is set the amplitude. By just saying amplitude, I'm going to set it to 1. And then I could say wave.frequency. I'm going to set some frequency. Let's try 300, whatever that might sound like. And then I'm going to play it. I think I need to say play or start. I'm not sure. Let's look at the reference page. It looks like starts the oscillator, and there's a nuance to this function which I think will be interesting to see. So I'm going to say start. So let's refresh this sketch. Can you hear that? A nice tone. Let's go back. It's very hard for me to hear it the way I have the sound configured for let me make this 400. That sounds very similar. What did I do wrong? So maybe that frequency function isn't correct. Let's look. Let's look back. Frequency. Okay, I need to look at the chat. I lost the chat. 261.626. Sorry, everybody. Sorry. I did it again. I'm so sorry. I'm so sorry. I'm so sorry. I can't. This stuff is very quiet for me. Yeah. Sorry, everybody. I won't do that again. I had a very bad feeling that would happen. When this gets archived, I need to remember to add an annotation that warns people that that's about to happen. Okay, so I won't do that again. First of all, let me make it quieter. Doesn't sound like a sine wave. I'm gonna come back into the. I can't. Oh, I muted the tab. Okay. Oh, interestingly, there's probably I know what the issue is. Shouldn't be out of draw. So I think there's an issue which is like a kind of very classic JavaScript problem where it probably takes some time to actually create the oscillator and it's not ready for its frequency to be set yet. So if I put this in draw, you're going to hear the difference. So probably the same thing with, yeah, that's a little bit quieter, right? Okay. All right, so okay. Okay, sorry everybody. Okay, I think I am now, okay, clearly what I need to do is build in a button to start and stop it, because otherwise it's gonna drive everybody crazy. Oh, docs imply it has to be after the start call. Oh, so maybe that's just the issue. Thank you. 400, 1200. Yep, thank you, Oliver. Always, Oliver, always. Okay, so before I go back into the tutorial, I'm gonna add a. I'm gonna just add a. I'm going to add a button so I can quickly stop a sound. I guess I should do this in the tutorial. Maybe I'll do this in the tutorial. I wonder if it says if wave. I wonder if this works. Oh, you know. Wonder if this works. Yeah, so that's not a function. I need my own Boolean variable. I just want to add this in here. Okay, so I just wanted to add this in here because and then also I have a reason. I've done way too much outside of the tutorial now. This is probably a bad idea, but let's see how that goes. Whoop. Why is that not working? Do I have two function draws? Oh yeah. Causes distortion. Okay. Okay, sorry everybody. Is this okay? What I have now? Please, someone in the chat tell me that what I'm playing right now is okay and won't hurt everybody's ears. Okay, great. Okay, so, whoops. I'm going to go back to the tutorial. Now, I think maybe what I'm going to do is I'm actually going to take this and put this up here. Okay. Okay. Okay, great. Thank you, everybody. Thank you for your patience. I'm going to cycle the camera since that was like a bit of a break here. And now I'm back. Okay, so the things that I'm going to do, I'm going to go back into, and this will get spliced together as a video tutorial. The things that I'm going to do, first I'm going to mention how you have to have start first, which it says in the documentation if I just read it. Then I'm going to show how I can change the frequency. Then I'm going to mention how I have a button there, and I'm going to put this stuff with the playing Boolean variable. And then I'm going to start to do some stuff like add a slider to change the frequency. I'm going to talk about yes, so Oliver asked, can I not just set the amplitude to 0.5 or 0 on the button press? Yeah, so I'm going to do that, and actually I'm going to actually change that live on the fly, I think, and just mention that as one solution instead of start stop. And then what's 440 is A, right? And then like something like 261 is like middle C. Yeah. Okay. But I'm gonna leave this as 400. Oops. Okay. Okay, everyone. So, and then I'm going to. Okay, so here we go. I'm going back. Try 432 as A. I actually have in this PDF a chart. I'm not going to worry about that right now because I'm going to do a whole tutorial about musical notes as a separate video. But okay, so let me come back here. Okay. Back again, there was an issue with the order of these operations. So setting the amplitude and setting the frequency will not work unless you call those after start. And it actually says that in the documentation. I just didn't read that properly. So what I'm going to do now is go back to the page and I'm going to refresh it. You can hear that 400. And I'll mention that 440, the frequency of 440 is actually the musical note A. You can tune your violin to it now. Can you hear that? That's the musical note A if I'm right. And I'll just mention that if I make that a little bit higher, if I say 1000, you should be able to hear that that's quite a bit higher. So let me go back to this. And actually, let me just turn the amplitude down to 0. And there you go. Now, you'll notice in this program, because hopefully I'm not blowing anyone's ears out, that I have a play pause button. So while I was taking a break there for a second to figure out what was wrong, I added that button. Let's just look at the code. So very briefly, there's just a button that says play and pause. There's a function called toggle associated with whenever that button is pressed. And then in that function, I have a Boolean variable that's set to either true or false based on whether this Boolean variable playing. And then in draw, I'm either coloring the background pink or gray, depending on whether that Boolean variable is true or not. So if I go back here and run this again, you can see playing that button toggles the background. So one of the things that I want to show you is that I can actually just take this code right here, and I can put that here in the toggle function, and then I could actually say wave.stop here in the else. So right now what I want to do is toggle that oscillator on and off. So I'm going to run this. Do you hear it? I think you do. Wait, I don't hear it. I don't know why I can't hear it anymore. Oh, the amplitude's at 0. So let me turn it back to 0.5. Okay, now you can hear it. Right? On and off. Oh, I think there's like a low hum. Anyway, hopefully the sound is fine. So I can toggle that sound on and off. Now there's a couple things. One I should mention is I don't actually have to start and stop it. What I could really just do is, start it right here in setup, and I could immediately set the amplitude to 0. And then what I could do here is just, and I could also set the frequency here in setup. And then what I could do is just set the amplitudes. So I don't need start. I just want to set the amplitude to 0.5 or set the amplitude to 0. So I'm going to run that again. I'm turning it off. Now, one thing I'll mention is, do you hear that little clipping? Each time I start and stop it, there's a quick clip of the sound. That's because this oscillator comes in at full amplitude immediately. So often with a sound like this, it's a little bit advantageous to kind of fade it in very slowly. And there's actually the amplitude function, and I believe start and stop, there's an optional second argument. So if I put in 1 as a second argument, it's going to take 1 second to fade in that sound or fade out that sound. And I could put in 0.1 or something much shorter if I want, but let's take a listen to that. Did you hear that fade in? Very hard for me to hear it because it's very quiet out of my speakers, but hopefully it's piping through the sort of YouTube recording system and you can actually hear it. Okay, so hopefully you heard that distance. Now let's talk a little bit about, let's do one more thing I think which would be worth doing. What I think would be worth doing is let me create a slider. And I'm going to say slider equals create slider. And now I need a range. So the audible, I believe a reasonable sort of audible range of frequencies is between 20 and 20,000 perhaps, but I don't want to blow out your ears. I'm afraid of doing anything too crazy. So I'm going to have a frequency range between let's just say 100 and 1200, which I think will be somewhat reasonable. And I'm going to start at the musical note A, 440. So I'm going to create a slider, and in draw, what I'm going to do is I'm going to say wave, usually when in the chat, if someone's blasting with emojis, I know that something's wrong, but I don't know what that is. Wave.frequency, slider.value. So what I want to do is now at least tie the frequency to a slider. And so first I need to play it. You can hear that. So you can see as I can change that frequency on the fly. So this is the basic idea. I can synthesize a sound as a waveform. I can fade it in, I can fade it out, I can change its frequency, I can change its amplitude. And I want to actually, let's just briefly, maybe we'll add triangle wave or sawtooth wave or square wave just to hear what some of those sound like. But mainly what I want to do in the next video is talk about something called an envelope. And an envelope is a way of kind of crafting around that oscillator, sort of musical attack, a fade in, a fade out. And that's going to allow us to configure the oscillator in a way that might sound more like an electric piano or a particular kind of musical instrument. We're not going all the way there to that. And then I want to talk about what are specific frequencies of specific musical notes, how do those relate to a concept called MIDI, and how might you create a program that sort of generates a tune or allows a user to interactively play piano. Okay, so So what I'm going to do here is so I think I'm done, but let's just look, before I go, let's look here at the oscillator object. Oh, I'm in frequency. Oscillator object, what I want to look at is this. So the options for set type, sine, triangle, sawtooth, or square. So let's just try a triangle wave and hear what that sounds like. See if you can hear the difference. It has a kind of different quality to it. And so what I recommend that you do, one thing you might think about as an exercise is, can you create a whole interface? An interface for changing the wave form, for changing the frequency, for changing the amplitude. What happens if you have multiple oscillators? Can you harmonize? So this, there's a bunch of things you could try here. And I also want to remember to make sure I do something where we visualize that wave itself. So where the wave is drawn on screen. So I should make that happen at some point too. Okay, thanks for watching this sound synthesis video. I look forward to hearing your feedback in the comments and the chat and all that sort of stuff. There's no chat, I guess, actually, after it's over. Bye. Okay. Oh, so I forgot to remove the stop function call. That's what Alvaro is saying. Oh, yeah, I did. Thank you. So that was a mistake, but, so it wasn't fading out properly. That's too bad. Here, let me record a brief addendum. This will go on the end of that video. It'll get edited in. Thank you, Mathieu. Okay. Hello, video epilogue. I realized I forgot actually to remove wave.stop in here when I was showing you that you didn't need stop, that you could just fade the amplitude down to 0. So I'm going to actually take that out, and I'm going to go back, I'm going to run this again, hit play. Hit pause, and pause is probably the wrong word. It's fade in, fade out, and I could make the text of the button change. All sorts of stuff I could make this better, but at least that was a brief correction. Okay, thanks for watching this video. Okay. Okay, thanks for that correction. All right, how's that? Any feedback, any questions? It's 11:50. Let me look at my list here. So I think that counts for this particular topic, and I think that I want to look at envelopes. I need to add something to this. Am I allowed to edit this here? No, this is like my public version of the Slack file. I think I have it on the other. I want to add something, I think, which is visualize the wave. Hold on, if you'll bear with me for a second. I'm going to try to add this to my to-do list, wherever that is. Impossible to sound tutorial outline. I should be able to add here. Edit. This is not very interesting because you can't see what I'm doing, and I also can't figure it out. This is a list, keeping these lists in the Slack channel, and I don't see how to edit this. Add reaction, view public link, open a new window. Let's try opening a new window. Yeah, lets me edit here. So visualize sound wave. So I want to add that. Hit save, hit refresh. I don't know why it didn't show up here, but I added it to my list over there. Okay, I'm not going to get too caught up in that. Let me check the chat again to see. Let me look at the chat. So Michael Berger posted something about the solar system 2D example not working because of the recursion. I'll have to check into that. Not working in P5.js. That was an example I made in processing. Rosling in the chat writes, if it's not too off topic, would be awesome to show one oscillator star times another one. Okay, interesting. It's not too off topic, but it's a bit beyond the scope of what I'm prepared to do with these basic ones, but maybe remind me later. And then, Darth, yes, I saw your comment about the train generator not working. I'll have to check into that when you change the width and height. I'll have to check into that. I probably have it. It has to be a square or something. I'll have to fix the code for that. Can you natively mix multiple sound files in processing? why would you do it in native Java, or would you do it in not native Java? Okay, so one thing I'll mention that's just kind of something to sort of think about. So I'm using P5.js. There is also a processing sound library, which has a very, very similar API as the P5.js one. And you can do a lot of this stuff. And you can actually mix two different sound files, I believe, in the processing version. Okay, any other questions or feedback? I think I want to do another, I think what I would like to do today is, at least, so in the amount of time that I have left, it's about noon. I have about another, this has been going for, I have about an hour in me, I think. I'm definitely gonna have to take a pee break at some point. But I have maybe an hour in me more. So I think what I wanna do is do envelopes and then do the super shape. That's kind of my plan for the rest of today. So sound envelope. So let's go look again at my learning processing chapter. And somewhere in here, so this I wrote, okay, so this, by the way, hopefully this is accurate. This is a chart which shows different frequencies for different notes. And an envelope is something, okay, I wrote, a more sophisticated way to simulate a musical instrument playing a note can be accomplished with an audio envelope. An envelope controls how a note begins and ends through 4 parameters. I hope that's right. Attack time, that's the beginning of the note, like the moment you hit it on the piano. So how long it takes for the volume of the note to go from 0 to its peak volume. Sustain time is how long it takes to play. Sustain level is the peak volume of the sound during its duration from attack to release. And release time is the length of time it takes for the level to decay from sustain level to 0. Okay. Carlos, by the way, asked in the chat, can you do AM and FM synthesis in P5.js? Probably. And I need to, okay, so this, so let's look at, now I'm going to go to the reference, and let's look at P5 envelope. And this uses something, okay, so let's read this. This is a kind of envelope known as an ADSR envelope. Attack, decay, sustain, release. Well, that's a new song for us. Attack, decay, sustain, release. That could be a song. Lin-Manuel Miranda, I am not anywhere close. Okay, so an envelope can control an oscillator's frequency. Set range to change the attack release level. Use set ASDR to change the attack. Okay, so let's look at an example here, probably, where you create an envelope, you set its ADSR, attack level, release, attack time, decay time, sustain percent, release time, and then attack level, release level. I gotta understand what those are. Those must be the amplitudes. And then what you do, sorry, I'm learning this, is the envelope is the thing that you play. Oh, no. Envelope.play. So how, this is kind of, what's one of the things that's often a little bit confusing to me about the P5.js sound library is that it looks like it will tie these things together by default. Like nowhere in the code do I say, use this, oh, no, there it is. Amplitude is with the envelope. Okay, so that's how the envelope is tied to the oscillator. So the oscillator, so let's, okay, so let's see what happens here. Clicked away. You guys hear that? So attack level, release level, attack time, decay time, sustain percent, release time. So if I were to edit this and have the release level be 0.5, for example, it releases not to 0. Okay, so that makes sense. The attack time, if that were like a full second, you can hear it takes a second. And if I make the decay time, the release time. So what's the difference between decay time and release time? Wait, I wrote this. So this is sustained. I call these different things: attack, decay, sustain, release. Boy, maybe my book is wrong. Attack. So I don't want to actually look at this right now because this is wrong. But it got me going. This is a good thing to do. So let me understand this before I make the video. Attack, decay, sustain, Okay, I should be back. I'm going to check the, I'm in the wrong place here. I'm going to check YouTube chat to see when if you're watching on YouTube and you see me again, let me know. Also, can you hear my audio? It's not doing that horrible looping thing anymore. And then, unfortunately, I had to all my settings got lost when whatever crashed. So I got to play some sounds again. I don't have it within me to do my ridiculous dancing thing. This is me being like tired dancing after like an hour of live streaming. Somebody can make a GIF out of that, I'm sure. How is that? Is the level fine between those two sounds? Okay, hold on. I did get some water. Okay, so here I am again. I kind of lost my momentum and energy, but hopefully I can gain that back. And let me come back here to where I was. The fortunate thing is that did not happen. The sound issue. This has happened to me before. I don't know why it happens. There's something going on with, I have like a lot of different USB connections into the computer, and I noticed when this happens, like the mouse, the keyboard stops working, but I can remote desktop into the computer. There's something going wrong with like all the USB connections get on the fritz. Maybe I need like a USB hub or something. Anyway. Okay, I think I might actually be broadcasting to Facebook now because it didn't work before. But so hello, Facebook. This is actually the second half of a live stream if you're watching. The full thing will be an archive on YouTube at some point if you want to go over there and look. Okay. All right, so the thing that I'm on is 12:15. I've got about 45 more minutes, I think, to go here. I'm going to see if I can get these two things done. I want to do a video tutorial about audio envelopes. And this is my new reference for an ADSR envelope. The attack is the how long it takes to get up to its attack volume. Then the decay is how long it takes to get to its sustain volume. And then release is how long it takes to go down to 0. And so then if I look at the P5 example, these are the attack time, decay time, sustain percent, release time. And then this is the attack level, but shouldn't this be the sustain level, right? No, that's the release level. So, oh, this is the sustain volume. Got it. So it's not, it would go, so what happens if you don't set the range? This is my question. So like, for example, right now I have an attack level and a release level. So what if I just make an attack time and a decay time and a sustain percent? But if I take out, if I don't bother with this, is there some default? Yeah, so it must be, there must be some default levels. So this is really confusing because there are three different volumes, amplitudes. There's the first amplitude, the sustain amplitude, and the end amplitude. And then there's three different like moments. There's the attack, how long it takes to get to the first volume, the second one, and the last one. Okay. All right, everybody. So I think I'm ready now to do this tutorial. Let me keep this page open. Definitely, this page I'm done with. This is a good one, I think. Is there a way I can, I just want to kind of, I think I want to do this if possible. Yeah, this is better to look at. Okay. So this is a nice diagram also that I think I will use instead of having to do my own. This is the reference page for envelope. So I'm going to come down here. Might need this as a reference. And this is, oh, okay, so now what I need to do is go to the sound folder. So this is going to be Sound Synthesis 02. And in Atom here, let's open up Sound Synthesis 02. So what I want to do is get rid of the slider, simplify. I don't need this playing thing anymore. I need a button. I need an oscillator. And let's set it to sine. And get rid of all of this. Okay, so I just want to simplify this to, oops, sound synthesis 2. Playing is not defined. False, okay. So is that working for you guys? It's fading in and out? Okay. Okay, great. I don't see anybody yelling at me in the chat that anything has gone horribly wrong, so I think I'm ready for envelopes. Yay, envelopes! Yay, envelopes, I need some energy. Envelopes, yay, attack. A, D, S, R, A. It's like, I'm like a cheerleader. A, D, S, R. Attack, decay, sustain, release. Okay. All right, I think I'm ready for this. Yeah, definitely don't quit my day job. That's for sure. All right, so let me erase this over here. Okay. By the way, sorry, I'm over here erasing the whiteboard. I just needed a break from the camera. So. Okay. Okay. Coming back. I'm going to have a little water. Here I am. Hello. This is even better. Watch this. Let's see if I can make this happen. Going up an escalator. Okay. All right. So let me. Do I dare have this diagram open when I begin this particular video? I guess I will. Okay. Let me cycle the cameras. And I'm going to get this done. Okay. Here we go. Okay. Oh yeah, we need a screenshot. Thumbnail. Okay. Those are some thumbnails. Okay, here we go. One, it's really hot in here. I've been doing this it's a hot day in New York. Okay, I'm recording, I'm streaming, and I'm ready. Hello, welcome to another video tutorial about sound synthesis. And in this video, I am going to look at something called an envelope. It's, you know, if I had an envelope in front of me here, I would open it up and reveal the winner of, I don't know what, some sort of bizarre coding tutorial awards show thing, and then I would thank my mother and my father, and it would be very awkward. The orchestra would try to play me off, but that's not what I'm doing here today. That really did not need to be in this video. But anyway, but envelope. This is the reason why is this. The thing is, this envelope thing that I'm about to talk to you about is a really quite lovely and simple idea. So I gotta just start over. It was too much. Nobody wants to watch that at the beginning of the video. Okay. It's so hot in here. I'm dying. Okay. I'm gonna do a revised version of that joke. But to keep it, I'm gonna keep the joke. I don't have an envelope. Wait, let's see if I can find one. Oh, actually, you know what? I totally have an envelope because I have some tax forms. There's got to be an envelope in here. Right? You got like tax forms, check, reimbursement from the dentist, insurance. Here's an envelope. No, there's no envelope. All this paper. You guys really just want this tutorial, don't you? Okay, sorry. Here we go. I thought I had an envelope. A prop. I just aspire to use props. I don't have an envelope. I'm looking around. Oh, wait. Look. Envelope. Okay, here we go. Ready, everybody? Hello and welcome to another sound synthesis tutorial. This sound synthesis tutorial is about envelopes. And the winner is... Oh no, I don't know what I've just done. The winner is the P5JS sound library. Okay, none about that. Okay, what I'm really here to talk about is this kind of envelope. And this looks like kind of a very scary, weird looking diagram, but I'm actually hopefully gonna make it make sense to you in this video. And I've lost my marker, here's the marker. What I want to talk about is something called an ADSR envelope. And envelopes are used in the world of sort of sound synthesis as a mechanism for adjusting the way the playback engine enters and exits the sound. And so you could essentially configure, in the previous video I made this oscillator object that played a sine wave, and the idea I'm going to wrap that sine wave in an envelope, open up the envelope and put the sine wave in it, and that envelope is going to configure how that sound, and you can get very sophisticated with this to make sounds that sound more like one or different kinds of musical instruments. But really for us in this video, I just want it to sound kind of like an electric keyboard in a way. Electric isn't really electric, I don't know if that's what you say, but you press a key and you hear the sound go bung, bung, sort of attacks, fades in and fades out. So in P5JS, there is an object called a P5 envelope. We had a P5 oscillator, now I'm going to add a P5 envelope, and we're going to link them together. And the reason why it's called an ADSR envelope is because there are 4 stages. Now I have that diagram here, but I think in order to understand it, it would help for me to try to draw that diagram. So there is A, which stands for attack. There is D, which stands for decay. And there is S, which stands for sustain. And then there is R, which stands for release. Okay, now the interesting thing about this is there are 2 kinds of things that are involved in an envelope. There's stuff that's measured in time, and there's stuff that's measured in amplitude. So, and interestingly enough, attack, decay, and release are all amounts of time. So attack meaning the moment you press the key on that piano or keyboard or whatever, that's attacking the note. So how long does it take in time to get up to what would be thought of as the attack amplitude or volume, the level, okay? So attack is how long does it take to get up to that. Decay is how long does it take to get down to its regular volume. So there's a volume, it could be loud at the beginning and then sustain at a different volume. So that's how long it takes to decay. And then sustain, so this is time. Decay is time. Sustain is actually amplitude, a volume. So this is how loud is that sustain level. So this is a value measured between 0 and 1, kind of percentage volume. And then release is also a time. for how long it should take to fade out to its release amplitude. So we have, what's interesting here is we have the attack time, the decay time, the sustain volume, and then the release time. Interestingly enough, though, we need an attack volume and a release volume. So let's say the sustain volume is 0.5. But when we attack it, we want it actually to ramp up to 0.75, then fade down to 0.5, and then fade down to 0. So there are two values missing from ADSR, which is the attack volume and the release volume. And in P5, when you create the envelope, when you say new P5, actually you just say P5 envelope, sorry, there are two functions. I can't remember what they're called. I think one is called set ADSR, and you give it 4 arguments, which are these values: attack time, decay time, sustain level, release time. And then there's another function which is like set, I'm going to come over here and quickly look it up in the reference. Set range, okay. Then the other function is set range, and boy, this pen is not working very well. I don't know if you can read this. And those are those last 2 volumes, this attack level and the release level. So we need to configure this envelope. So let's go into P5.js and now make that envelope and configure it. Coming over here. Hello. Okay, so you can see, by the way, now we might understand this graph, this chart a little bit more. Attack time, then decay time, what's that sustain level, and what's the release time. Okay, now, so let me go back to my code. This is by the way, so this is where I kind of have an example built off of the one from my previous video, where all it does is play an oscillator. Do you hear that? I think it's playing the musical note A, 440 hertz. And then I can turn it off with this button. So what I want to do is, instead of just having it be just a pure oscillator that just plays forever, I want to create, and I'm going to just make a variable called env for envelope. I really just want to use props. Envelope is kind of a lame prop, but it is a prop nonetheless. Then I'm going to say here, I'm going to say envelope equals new p5.envelope. And I'm going to say envelope dot, what did I say? Set ADSR. So now I need those 4 values. Attack, decay, sustain, release. Attack, decay, sustain, release. Okay, so attack is, let's just say we're going to have a 0.5 seconds for the attack. Then we're going to have 0.25 seconds for the decay. Then our sustain volume is going to be at 0.5. And then the release time is going to be 0.1. So I'm kind of making these up, the arbitrary configuration. Then I'm going to say set, what did I say, set range. So I want the attack volume to maybe be at 0.8, so a bit louder. And then I want that release volume to be down at 0, because I want it to fade all the way out. So now I have, if we look at this code, I have the envelope and I have the waveform. So I need a mechanism by which I connect the envelope and the waveform together. I want that, this is the waveform, this is the envelope. I want to take the waveform and I want to put it in the envelope. Oh, that really made sense. Over here. Okay, so the way that that's done is with the amplitude function. So typically with a waveform, I would set the amplitude to like 0 or 0.5 or 1. But actually what I want to do here is set the amplitude to that particular envelope. So now this is how they are connected. The wave's amplitude is set to the envelope. And then in this play function, I actually don't need all this toggle stuff, because all I want to do is just say envelope.play. So I want the envelope to play. It's going to play that oscillator wrapped in all the configurations of the envelope. So let's see. Hopefully this is going to work. I'm going to refresh it. P5 envelope is not a constructor. New p5.envelope. What did I get wrong there? So let's have a look at this page. New p5.env. So it's not the full word envelope, it's just .env. Okay, thank you very much. .env for short. Then I'm going to go back to my program. I'm going to run it. Do you hear that? Now, does that really sound like playing a note at a keyboard? I don't know if it does. Let's mess around with it. Let's make that attack time very, very, very short. Let's make the decay time also shorter. And yeah, so let's make the attack volume like a little bit louder so we can sort of hear. And maybe the release time can be much longer. Do you hear that? So there's like sort of a loud pop and then a little bit of a sustain and then a fade out. So, now hopefully this explains the idea. Now you can, to your heart's content, I might suggest make a sketch, tie all these to like buttons or text boxes or sliders, configure the envelope, have it play, change the frequency each time you play a note, have a slider to set the frequency. You can sort of set something up to test how this works and to kind of get good at, and I'm sure if you research like standard ADSR values for particular instruments, you might try it with a triangle wave instead of a sine wave. You're going to be able to maybe control how the sound sounds a bit more. Now, I should mention, by the way, I'm doing this sort of basics of generating tones with P5JS Sound Library. There's another library you might look into at some point called tone.js, which also has a lot of features for doing this kind of work and pushing it further. But what I want to do after, in the next video, is show you now how to keep track of an array, a list of different musical notes, how to set an envelope and have an oscillator and play a melody and possibly also a harmony at the same time. So now we've got the basic idea, but how do I turn this into something that actually will manage time, play notes, or be interactive, that the user could press keys on the keyboard and play certain notes, that type of thing. And I'll do that in the next video tutorial, which I will get to at some point, perhaps. If you're watching this at some point in the future, it's already there. Okay, thanks for watching. Goodbye. Okay. I think that worked. Could you guys hear that? One issue I'm having is with the way I have the sound system set up, I can barely hear what the sketch is playing, but I'm pretty sure it's piping in through the stream and recording system. So, thank you, Alvaro. Alvaro is giving me a correction, which I think is really important. Yes, it was audible. So I want to read this. I'm just going to read Alvaro's comment. Sustain level is the percentage at which the amplitude stays while the key in the piano or keyboard synth is still down. The release time is the time it takes to fade out when the key is released. So I wonder what default amount of time it's considering the key pressed when I just say envelope.play in P5JS. Maybe I should make a little addendum to that video. Does anybody know the answer to that? If only Jason Siegel were watching this video in the chat right now, he would be able to say. So hold on, I have to look. Trigger release. You should also talk about trigger attack, trigger release. Okay. I'm going to make an addendum to this video. This is my new thing. Okay, let me take a look at that in the reference page. So play tells to start acting on a given input, sound object and the envelope, right? Okay. Okay. I will explore this. I'm going to just add a one-sentence explanation at the end of the video. And then I will explore trigger attack and trigger release in a separate video, possibly in one of the next ones. Thank you, Alvaro, for that correction. That's a really important one. So let me get to your comment so I can. I'm going to do a quick addendum, which can get edited onto the end of that video. This is a new thing that I'm doing. Okay. Oops, I'm back again with another addendum. One thing that I never actually talked about was how long should this note sustain itself? And you notice that's not really actually a variable anywhere in this. There's no sustain time. So the reason that isn't is because typically the way these envelopes are implemented is if you're thinking about playing a piano or a keyboard, the note is sustained as long as you're holding down that key. In some default amount of time, I guess, is being used, but there is also the functions trigger attack and trigger release. So you can trigger the attack, instead of just calling play, you can actually trigger the attack for that envelope and have it sustain for an arbitrary amount of time until you trigger release. And that allows you to do a few more things with how you control the envelope and the playback. And I'll try to do an example in a later video which uses trigger attack and trigger release. Okay, thanks for that little extra note. Or watching that extra note, that is. Thank me for the extra note? I don't know. Okay. Okay. Mouse down and mouse release listeners. Okay, so let me I'm not going to do that right now. That would have been good to add to this. But I'm going to just make a note of that in my, whoops, in my, so I need to do trigger attack, trigger release, mouse down, mouse released listeners or keys. Okay, thank you, Alvaro, for that excellent addition. I just put it in my notes. I don't know why. Let's see if it shows up here. Yeah, so you can see it there. Yeah, so I made a note here that I will do a video. I'm done with the sound stuff for today because it's already 12:40, and a lot of people requested the super shapes thing, so I want to make sure I do that today. What was I saying? So far, basically, I've done this much so far, I think. Yeah. So I need to do this. I want to visualize the sound wave, melody generator, or like, slash piano, keyboard, demo. And let me hit refresh here. Whatever. I don't know why it doesn't show up here immediately. Okay. Let me go back to the chat. Let's see. Whoops, I lost the chat. There's a discussion about artificial intelligence in the chat going on. Yes, I'm of a mind to at some point do some machine learning tutorials. If you're looking for this content, my two recommendations would be look into the work of Rebecca Fiebrink. I hope I'm pronouncing her name correctly. She has a Cadenze course called Machine Learning for Artists. I'm sure if you Google Rebecca Fiebrink Machine Learning for Artists, you'll find it. And also you can look up the work of Gene Kogan. And if you also Google Gene Kogan Machine Learning for Artists, I don't remember, I don't know, maybe one of their courses is called something slightly different. He has a GitHub repository and a set of screen captures, which are a bunch of different tutorials, and I know that the Rebecca Fiebrink in particular had developed something called Wekinator, which is something that I would like to at some point maybe make some tutorials about, but you know, to me, Rebecca and Gene are some of the people who are doing the sort of primary work in this field in the sort of arts context, and I would look into their work in particular, and I'd be glad to try to be inspired by them to make my own tutorials, but it's certainly not something I don't feel, but I do have it on my list. It's certainly been requested a lot. Okay. With regards to, Oliver writes, with regard to the sustain time in play, the default for that third parameter is 0. Okay, interesting. Okay, so now, so I'm done with the sound stuff. So give me a minute, everybody. I would play you some music in the background.
Cutting rainbow. Cutting power.
While the music's playing, I need something more relaxing. I need a relaxing music option where I can just do this. I'm going to try to get myself set up to do the last thing of today, which is the super shape. So what I need first is super shape Paul Bork. It's so hot in this room, I can't wait to be done. So I've got the formula there. I'm going to go to Coding Rainbow. I'm looking for super, I already have, interestingly enough, I guess I did it already. So I'm going to copy this super ellipse and call this super shape live. So I guess I have one that I'll check, and then I'm going to go in terminal. Where's my terminal? Go up a directory, Coding Rainbow, run the server again, go back to here. So let's look at, apparently I did this already. Let's just see here. Yep. Okay, so this is something I practiced with. So this is the super shape code, basically. But what I want to do is start from here, which was my super ellipse example. And let me go there. And Did I just close Atom? Supershape Live. Look at the sketch. Now I kind of want to look just briefly at the code that I did already, just to like get my. Okay, right. So these are the variables. Then I get m from a slider value, and the step is 1. I remember this now. And then I'm still doing this thing where I'm doing the loop and setting vertices, calculating the formula, and then calculating r, and then getting x and y from that. Okay, because I just need a point for every angle, and then also here. Okay, so I think I should be able to do this. Let's find out. Okay. Ah, boy, it's hot. Okay, I can do this. It is 12:43. I hope that this will be 15 minutes or less, and that. Oh, good thing I noticed this. This is an issue that I have to fix. This particular folder, for whatever reason. Ah, that's weird. I don't know what. Why? Oh, okay. No, I'm fine. Okay. Okay, here we go, everybody. N1, N2, N3, and M. Those are the variables. Okay. I can get rid of this. I didn't give credit to this diagram, but oh well. I can get rid of this one, and I can get rid of this right now. And oh, I see. It's synchronized the supershape ellipse with some oscillator. Now I finally, so that's a good, honestly, it's a great suggestion. I would love to add that to the tutorial. To me, that's sort of like an exercise to do once I have the particular code written. So what I'm gonna do is I'm gonna control it with a slider, and certainly you could then take that value that's controlling it and use like a sine wave. I did that with the Julia set yesterday, so the Julia set code actually has the same code to do that. Does this supershape allow you to change the vertices of the shape at different points? Well, I'm going to just do the raw algorithm, and then when I'm done with that, you guys can ask some questions in the chat. You can see, but hopefully you guys can like make your own ideas and versions out of this. Okay, so let me go to here, and this should be good. Is both the equation of the sphere and ellipse and even the super ellipse given here? The general formula for the super shape is, okay. All right, everybody, settle down. This is the last thing I'm going to do today. I have a long list of things we're going to get to as I'm doing these live sessions every week, once a week or twice a week. You can join the Patreon and the Slack, where I have a particular channel which is dedicated to discussing the topics that I'll do in future videos. Okay, so here we go. I'm going to cycle the cameras. And one thing I need to do very briefly is just clean the whiteboard in case I want to use it. So I'm just doing that right now out of view of the camera. Okay. Out of view of the camera. There we go. Everything's still working audio-wise, et cetera, I hope so. And I think I'm ready. Whew, I hope this goes well. Okay. Okay, I don't know what people are discussing in the chat. I see lots of messages going by. Ready? Here we go. Hello, and let me start over. I'm so tired, hungry, and so hot in here. Last thing, here we go. Hello and welcome to a video tutorial about programming something called the SuperShape. Look at that formula. I'm going to do this in JavaScript. I'm going to use the P5JS formula. This is a topic which is a continuation of a previous video that I made about the super ellipse. I'm essentially going to use the exact same code I had in my previous super ellipse video and turn it into this other more elaborate formula called the SuperShape. The SuperShape this is Paul Bork's website. I'll include a link to it in the description. This is a page documenting how to do this from 2002, and the equation is something based on Johann Gillies. I'm not sure if I pronounced that correctly. And these are formulas that are designed to try to simulate and create different kinds of natural forms. And eventually, if I am strong enough, if I'm courageous enough, if I can manage it, I'm going to, in the next video, finally look at the SuperShape in 3D, which allows us to start creating forms that look like this sort of stuff. But at first, we just want to see if we can make these 2D-like forms with different parameters for this particular formula. So let me come back, and here is the formula. Okay, so what's the core idea here? Let me come back to the whiteboard here for a second. The core idea, if you've forgotten, is that I have this idea of a polar coordinate system. So I have some r and some angle. And actually, what I'm going to do is I'm going to iterate over every possible angle from 0 all the way to 2 pi. And actually, you can generate interesting supershapes by doing this multiple times. So going like from 0 to 2 pi like 6 times. And what I'm going to do is with this angle, I need some way of calculating r. So that, for example, if one of the supershapes might look something like a flower, that r is changing based on the angle in a way like it's oscillating. Almost like you could just sort of do this with a sine wave. Like you could say, r equals sine of the angle, which is actually giving me like a backwards headache because there's so much wrapped up. But anyway, you get the idea. I need to calculate r from theta. And in fact, that's what this formula is doing. It's saying 1 over r equals all of this stuff, and phi being the angle. Or I'm saying theta, I think that's the Greek letter phi or phi, or I don't know. Everything's going wrong today. And I can flip this. 1 over r equals that, so r equals that. So I need to figure out a way of getting this formula in my code. It's going to be a bit awkward. I'm sure I'm going to make some mistakes. But the other thing that's really important here is that looking deeper into this formula, there are 4 constants. Oh, a and b, by the way. Okay, so there are actually more than 4 constants. There's like 6, I think. There's a, b, m. That's not 6. Yeah, it is. A, B, M, N1, N2, and N3. So based on those values, you are going to get a variety of different results. And you can see here, if I look at this page, you can see with different values of M, you get these different results. So hopefully, I'm going to do this correctly, and we'll see the results that are that are on this page. So let's go to the code, and this is actually just the code now that I picked up from the super ellipse. And you can see I'm running this here. This is the super ellipse, which is just changing one particular parameter to create these different kinds of ellipsoid patterns. And I am now going to go over here. I actually don't need this particular function, and I'm going to the thing that I'm going to leave in here, which is the most important thing, is this. So ultimately what I need is begin shape, end shape, every single angle, and I need to get an x and a y, and I need to draw that vertex. So this I need. And then I'm not going to worry about the slider thing right now. We'll come back to that later. What I also need is I need to have a bunch of constants. So I'm going to say I have n1. I'm going to have n2. I'm going to have n3. I'm going to have m. And I'm going to have a. And I'm going to have b. Now for simplicity right now, let's make everything 1. And obviously, you can declare and initialize variables all in one line in all sorts of fancy ways. But I'm just going to be very explicit about it. Those are all of my constants. So I need to go back and forth. I need 2 screens, really, because I really need to refer to this formula quite a bit. But I think what might make things nice, and actually, Paul Bork has code for doing this here, and I guess I could check it if I get confused or something wrong. But what I think would be useful to do is to create a function. And I'm going to do that up here. And I'm going to create a function called SuperShape, and it gets an angle. So this function receives an angle. Maybe I should call it theta, A for angle, it doesn't matter. So it receives an angle, and it needs to return back r, because that's what I'm trying to calculate. So at the end, I want to return r. So let's see somehow, and I want to say var r equals 1. So let's just say right now, let's say this is my function. And then what I want to do here in this code is I want to say var r equals supershape of that angle. And then I need to say x equals what? R times cosine of that angle. Y equals r times sine of that angle. And if I wanted to, I could also like scale these up by some arbitrary value. And I'm going to make that a separate variable like radius, just to scale them up. And I could probably build that. I'm doing something like ridiculous right now, but I'll fix this later because it's returning 1. So the idea here is I should just see a circle. OK, great. So this is working. The idea here is that I have a function that takes the angle and sends back a value. And then when it sends back that value, I do it for every angle, and I get this circle. Now, of course, I'm getting a perfect circle because no matter what the angle comes in, I'm just returning 1. And now what I need to do is I need to get that super shaped formula in here. So let's try to do that together, and hopefully we get something that looks about right. So I'm going to go back to Paul Bork's site one more time. And so there's a bunch of things I need to calculate. One is 1 divided by a times cosine of m divided by 4 times theta. Ooh, am I really going to be able to remember this? I'm going to call this, I need some, I'll call this part 1. I did something terrible. So there's a constant called a. So this I don't want, I want this to be called, I'll call this theta. So 1 divided by theta times cosine of m divided by 4 times that angle. That's not theta, that's 1 divided by a times cosine of theta, which is the angle, times m divided by 4. OK, so that's this thing in here. So then I need to take the absolute value of that. And then I need to raise it to an exponent, which is n2, which is to the n2th power. That's part 1. Now I need to do part 2, which will probably be somewhat similar. Part 2 is 1 divided by b times sine of the same thing to the n3 power. OK, so what did I say? 1 divided by b and sine, those are the only things that change. And then this obviously needs to be part 2. Part 2, this is n3. Part 2, part 2. OK, so now I've got that formula there in 2 different parts. By the way, this I think is a useful thing to do. You got this big elaborate formula rather than to try to write it all out in one line of code. So divide it into parts. OK, so we got that. Now let's see. OK, now I need to add them together. So I'll say part 3 equals part 1 plus part 2. Then I need to take the square root of it. So I can probably do that just in this line of code. Square root, right? And then I need to multiply it by n1. So I just need to say n1 times that. So that's that. So that, oh, and this should be part 3 with no space. So this is mostly like me just like getting that formula in here. OK, I think we're pretty good shape. I think I'm doing this right. Please, please, please. Now what else? Ooh, 1 divided by r equals all of this. So if 1 divided by r equals all of this, r should equal 1 divided by all of this, right? I could just flip that. So I should be able to say, and actually I don't need this var r equals. I should just be able to say return, oh, there's a dangerous thing that could happen here. Return 1 divided by part 3. Now I'm a little bit afraid of a divide by 0 problem. So I think I better put something in here like if part 3 equals 0, then return 0. I don't know if that's correct. We'll look in. Oh, and wait, this is not n times. Wasn't there something? No, that is what. Yeah, maybe this is right. OK, so I think I got this right. And maybe there's something else that I did slightly wrong. But let's see if this is good enough. I have a working version of this. I can always check it if this doesn't seem to work right. OK, here we go. So let's just see what happens now if I actually let this be and let this go. Oh, and by the way, I had this like radius thing equal to 100. I don't need a separate variable. OK, so let's now run this. Ooh, look at that. That's promising. So I got something that looks right, but it's a slightly different shape. So let's actually go in. Let's go to Paul Bork's page. And how do I get over here. Let's look at an example with n1 equals n2 equals n3. Oh, if m is 0, I should get a circle. Let's at least test that. So let me make m equals 0. Ah, perfect. I got a circle. So I think I did the code correctly. So now if I go back here and I look at, with all these equal to 1, but if I have m equal to 5, I should get that shape. So let me change m equal to 5 and run it again. Close. Do I have something wrong? That looks a little bit different. That's a little distressing. Pause, time out. I'm going to see if I have a problem. Because, let me check my other example. I'm just going to see if I did it wrong in both examples or the other one. So the other one, if I set m equal to 5, and oh, this is annoying. I'm just checking my other one. Oh, you know what it might be? I might not have as much resolution in the number of points. What's the root wrong? The n-1th root. Oh, it's not the square root. It's the n-1th root. Ah, thank you. Thank you. I can't believe I made that mistake. What a terrible mistake. I just read that super quickly. Yeah, this is not the square root. It's not n1 times the square root. It's the n-1th root. Apologies for that. So let me go back here and let me just make sure this power of part 1 divided by n1, right? This should be right. That's the nth root of these two things. Let's see. There we go. That looks better. And you know what? I'm not getting, it doesn't look exactly right because I'm not doing, I could do more points. Like if here, like this is so arbitrary. Like I'm doing this in a silly way. Like you can see now, if I do more points, I get a better version of the shape. So I'm going to fix both of those things. Okay. So let me put that back. And what did I have? What did I have in my function? I had this. n1 times square root. Okay. So let me go back to the incorrect version. There we go. Okay. If I make the power -1 divided by n1, you won't have to invert it later. Yes, there's always a shorthand. Thank you. Good suggestion. Okay. Back now, I figured out the error. So I had a major error, actually. I completely read the formula incorrectly. This is not the square root of all of this times n1. This is the way that this is written means it's the n-1th root of all of that added together. In other words, if n1 is equal to 2, then it's the square root. So I really need to fix that in my code. So let me do that briefly, really quickly. So instead of n1 times the square root, I want to use the power function. Power takes something, and if this is like to the n-1th power, part 1 plus part 2 to the n-1th power, if I say 1 divided by n1 here, this is part 1 plus, this is the n-1th root of part 1 plus part 2. So I can do that, and then if I do it again, we can see, aha, now I have the correct shape. But you'll notice something, look at this. There's like a weird mistake here, and you can see it doesn't look exactly right here. So one thing I've done very not carefully, and let me fix that here, is that I just decided in my loop down here to just say, let me look at every single angle. Start at 0, go to 2 pi, go up by 0.1. Well, that's not very thoughtful, because 2 pi isn't necessarily perfectly divisible by 0.1, and it's not that many points. I could say 0.01, and I'm going to increase the resolution of what I'm drawing much more. You can see now it looks much more like that super shape, but I probably would make sense for me to be a bit more thoughtful of it, thoughtful and say something like, I want to have a total of 500 points, and then I want to have the increment, the angle increment, to be 2 pi divided by that total, and then I'm going to always go up by that increment. So if I just do it that way, then I could say this is 500 points. That's what I get with 500 points. And I could say something like, oh, whoops, I only want 10 points. And if you see that, you're going to see it still looks right, but there's only actually 10 points in there, and there's much less curvature because it's drawing big straight lines between some of those points. But this is, I think, a better way of being able to control this. With 100 points, looks like this. So how many points do I really need to get kind of like a good resolution on that shape? And when I do this in 3D, we'll need some sort of mesh. I hope I can do it in 3D. Okay, so let's look at this now. Now I have this slider down here. Let's at least do something like tie that slider to a particular value. So for example, what if I were to say, so one thing I want to do here is, one thing that's interesting is that I want actually the increment values of m to be incrementing by 1. So I want to start with an m of 5, and I want to go between 0 and 10. And then what I want to do here in the draw loop is just say m equals slider.value. So we can just sort of make sure things are, dot value. Make sure things are kind of working. You can see now, you can see as I move the slider, that shape is changing, and we're getting exactly what is written or depicted on this Paul Bork website. So you can see m is 4, I should get that, m is 5 is that. Now we can see, okay, what are these shapes here? What if I have n1 equals n2 equals n3 equals 0.3? Now I could change all of these, and obviously I could be much smarter about not having 3 separate variables if they're all the same value. And now we can see, what does this look like? You can see now I have this particular kind of shape, and you can see what it's doing as I change that value of m. So I'm going to stop here because I could continue doing this forever. I could say, oh, let's make sliders for all the different variables. Let's try all of these different possibilities. Let's see, can we get all of these different shapes? So this is what I would encourage you to do. And by the way, you don't have to tie them to sliders. Try tying those variables to like a sine function. I could do that really, really quickly right now. Like for example, if I have, I'm going to have a variable called like oscillate equals 0, and I'm going to say m equals map sine of oscillate, which goes between -1 and 1, to some value between 0 and 10, and then I'm going to say oscillate goes up by 0.1, and I'm going to refresh this. You can see now this is happening. It's happening very quickly, but automatically. So let's make it go up much more slowly. And you can see here what's happening is it's kind of like changing that value on the fly, and the shape is kind of like wrapping around itself, unfurling and furling. So there's a lot of possibilities here. I could add HSB and make it a rainbow, but I encourage you to explore this, play around with it, see what types of forms you can get. And eventually, at some point, I will get to that next video and try to do this in 3D to get a lot more elaborate forms. Okay, thanks for watching this particular video, and I look forward to seeing you in another one in the future. Bye-bye. Okay, so thank you guys for watching. Today it is 1:04 p.m. I don't remember how long. This stream has now been in 2 parts, so I'm going to have to do something with Mathieu's help, certainly to possibly edit them together and publish the archive as one long video. But hopefully you got something out of it. I think I got 3 new tutorials today: basic sound synthesis, sound envelope, and this super shape. So I also have another video tutorial that's in the backlog. So this stuff will get uploaded, and over the weekend and early next week I'll be releasing these standalone videos one at a time. By the way, if anybody's interested in the Patreon and the Slack channel, I offer downloadable Google Drive share access for all of my video files. If you want to watch this stuff online, you can subscribe to that. I'm going to just take a look at the chat for a couple minutes to see if there's any to see if there's any comments. You could randomly multiply each vertex by a number between 0 and 2 and look really spiky, says Michael. That's a great suggestion. You could use Perlin noise, for example. By the way, I did pee when I had that sound issue and I restarted the computer. I ran and peed, so I didn't make it this full 2.5 hours without peeing, which doesn't really happen to me very often. So by the way, Maysam says they're waiting for the genetic algorithm and machine learning series soon. I 100% am fully prepared to do genetic algorithm videos, but I was kind of waiting. The Cadenze course that I have running right now, the next session that opens up are genetic algorithm videos. So unfortunately, I don't have ownership over those videos to put them as part of my YouTube channel. Maybe that's something I can work out with Cadenze, but you'll be able to check that out. Michael asked, are there streams every day? Unfortunately, there are not. I would actually, I do have this sort of like pretend weird fantasy of moving to the country and having a garage and just doing this every day as my job. But currently I work, I'm on summer break right now, but I work full time at New York University at a program called ITP. Over the summer now, I'm kind of able to do this twice a week. I'm going to be away for a week in July and away for a week or two possibly in August, in which case there will be no live streams. But I'm committed to having 4 live streams per month. That's what I'm sort of saying for the Patreon that I have going. And my goal is to, in the fall, to be doing this once a week and actually be teaching my NYU courses along with this video series online. So, but we'll see how much this grows and whether it's useful or interesting to people. Maybe I'll become a person who does this every day at some time. But until I'm making enough money to support myself, I don't think every day is realistic. Okay. Oh yeah, so Darth, I think you're still asking about the array index out of bounds exhibit. I will try to take a look at that at some point. If anybody wants to take a look at that, there's an issue apparently with the code that I posted for the terrain generator, where if you adjust the width and the height, an array index out of bounds exception happens. So I will try to remember to look at that at some point. Yes, KNN classifier. I'd like to do stuff like that. That sounds exciting. Yes, Adrian asked, can you make a video that focuses on the difference between P5JS and processing? Yeah, maybe that would be a good idea. I have a gist. I need a good system for keeping track of all these ideas and ranking them. So I need help with that. Please help, particularly in the Slack channel, where I can kind of crowdsource this stuff a little better. Okay, those were some questions. Oh, I didn't make a thumbnail for this one, did I? Or maybe I did. But here. I'm trying to make thumbnails. Or GIFs. Okay. All right, so I think I'm going to be I'm saying goodbye now. Thank you again for watching, for tuning in, for your support, for your kind comments, for your feedback. You can get in touch with me on Twitter @Schiffman. You can subscribe to my Patreon to be a part of the Slack channel where I answer questions and discuss topics with a small group of people right now. I think we're about 20 people maybe in there. And I will be back not on Monday, I know, so likely on Tuesday. I don't know my calendar next week. And just to mention again, if you want email updates for when I'm going to do the live streams, go to codingrainbow.com. And you can scroll down here to find a place to enter in your email address. I send possibly 1 or 2 emails a week, just with like the time of the next live stream. And then of course, links to subscribing on YouTube are here and becoming a patron on Patreon. Maybe that should say something different. And oh yeah, look, is this me live right now? Look at this. Look, there's me live right now. So, oh, that's my previous live stream that I didn't make. I'm going to make that private in a moment till it's like, because I got to have all this edited together. Hey, you over there. What's going on? Oh, come on. Oh yeah, there you go.
I'm here again, live streaming. I hope
somebody can like GIF this together. There's a moment where I was dancing with myself, which was quite amusing. You should stop watching now. I'm just going to amuse myself for a little bit. Okay, somebody asked in the chat, what does coding rainbow mean? Coding rainbow is a reference to something called Reading Rainbow, which is in the States here, a television program and from the 80s. First episode was June 6, 1983, about teaching reading. And so it's just an homage to that. I love that program. I was 10 years old in 1983, so maybe I watched it. Oh, was that the dancing moment? I don't know where the dancing moment is.
really should do this before.
Whatever. Hey, you get better at this programming video thing. Oh, I got to do that disk bar. Oh, there we did that. Oh, look, there's me again. Okay, I'm going to say goodbye. Oh, cod in Grainbow. Yeah, I don't know what that means either. Okay, I'll see you guys. Thanks for watching. I should do like an Inception thing where then this video has me inside this video and that video and all of that. And I will see you guys later in the next live stream. Goodbye. Thanks for watching and all of that.
Here's my most recent video, which was about the Julius sets. And oh, you can also